Welcome to Science Makes Me Smile. Every idea begins as a question, not to settle the truth, but to explore it. What we discover along the way depends on how deeply we're willing to think. I'm young Dr. JGC. Let's begin.
Correlation or causality, the link between carbon dioxide and global warming. Determining whether an event or observation is truly random is far more complex than simply noticing a pattern. Human intuition is not reliable in this domain. We are naturally inclined to see order in chaos, which is why statistics developed formal tools to separate genuine structure from coincidence. The process usually begins with what is called a null hypothesis, the assumption that there is no real relationship between two variables. Statistical tests then ask, if there were no connection, how likely is it that we would observe data like this? The answer is summarized in a p-value, a measure of how surprising the data would be under the assumption of no real effect. But statistical significance alone does not establish causality. A small p-value suggests that the observed relationship would be unlikely under pure randomness. Yet unlikely is not the same as impossible. In large and complex datasets, apparent trends and correlations can arise by chance or through hidden variables. This distinction becomes especially important when examining the link between rising atmospheric carbon dioxide, CO2, and global warming. Measurements show that atmospheric CO2 concentrations have increased substantially since the Industrial Revolution. Global average temperatures have also risen over the same period. A statistical correlation between these trends can be measured. However, correlation alone does not prove causation. Establishing a causal link requires multiple lines of evidence. Laboratory measurements showing that CO2 absorbs infrared radiation, satellite observations of changes in Earth's radiation balance, climate models grounded in physical laws, paleoclimate data from ice cores, and detection attribution studies comparing observed warming patterns with those predicted from greenhouse gas forcing. The scientific case rests on the convergence of these independent strands of evidence rather than on a single statistical relationship. Distinguishing randomness from meaningful pattern, coincidence from causality, and correlation from genuine physical mechanism is an exceptionally demanding intellectual task. It requires careful modeling, replication, transparency, and deep expertise across multiple scientific disciplines. Climate systems are complex, involving interacting variables, feedback loops, and long time scales. For this reason, when politicians stand before the public and declare that the link between carbon dioxide emissions and global warming is settled science, it is reasonable to examine how that conclusion was reached. Scientific understanding develops through accumulated evidence, peer review, and ongoing testing, not through rhetorical certainty. Evaluating the strength of the evidence and the scientific credentials behind such claims helps distinguish between informed scientific consensus and political messaging.
Every conversation leaves a trace, not of certainty, but of insight. What you do with it is up to you. I'm young Dr. JGC. Until next time. Comments, questions, suggestions are welcome. Please remember to like and subscribe. Science makes me smile.